Welcome to Found in Space, a science podcast for kids and teens. Our question is, why does Saturn have rings? Now, at first, this might sound like a very simple question, but there's actually a lot to dig into with this, a lot to explore. So let's get started. First of all, if we're going to talk about Saturn's rings, we need to talk about what are rings in general. So rings, they may look solid from a distance, but rings are actually lots of tiny, thousands, millions of tiny little pieces of material orbiting around a planet. Or not always a planet, but sometimes this could be around an asteroid or a comet too. So going around a larger body. We have found many ring systems in the solar system. So Saturn's the most famous, of course, but all of the major planets, so Saturn, Jupiter, also Uranus and Neptune, so our gas and our ice giants, have rings. And we've actually found rings around some of our dwarf planets as well. Haumea and Quaoar look like they have rings, and two centaurs that we've found as well. So centaurs, these, you could think of them like an asteroid that is orbiting around the sun. It's still going around the sun, but it's very far out. These are far beyond the asteroid belt, and they come in close and then they go really far back out. So they're orbiting in these really stretched out ovals as they come in towards the sun, and then they go back out pretty far. So rings are these little particles that are orbiting around the larger body, and there's so many of them that together they look like a big solid object. Now, how did we find the rings to begin with? So Saturn's most famous for its rings because they're the biggest in our system, but they're the first ones we ever found. And in fact, we can go back to when we first started using telescopes to study the planets. Now, Saturn has always been visible to humans. All of human history, we could look up into the night sky and see Saturn. Now, it actually depends because Saturn is a planet. So planets, these are the wandering stars. Our ancestors didn't really know what planets or stars were, but they were able to observe that some of them seemed fixed to not move compared to the others, relative to the other stars. Like if you look at Orion's belt, those three stars will always look like they're in the same position to us. But the planets, the wandering stars, they seemed to move. Now they could track the movement over time, but they didn't stay in the same place next to the other so-called stars. So that's why we knew that they were special. And today we understand that's because the planets are actually other worlds. They're other bodies that are also going around the sun. And we're not going around at the same speed. So sometimes we're closer, sometimes we're farther away. Sometimes Saturn's on the other side of the sun from us. Sometimes it's on the same side. So if Saturn is visible, we look up and we see it kind of like this beautiful, bright, really quite bright star. With a telescope, though, Galileo, back in 1610, so this is right after telescopes were even invented, he looks up at Saturn and he notices Saturn is different. When he looked at Jupiter, Jupiter looked round. When he looked at Mars, Mars looked round. But when he looked at Saturn, he noticed on either side there seemed to be these little balls, these little bulges. And in fact, at first, he described it as like three bodies. So there was Saturn in the middle and two little balls on either side. This is because he was looking with a very small telescope. With larger telescopes today, when we look, we can see that they're not other balls on either side of Saturn. It's actually a disk surrounding it. And that's what, around 50 years later, Huygens, who was a Dutch astronomer, actually determined that. He went, okay, so that it's a disk, they're not little balls or little moons. So we know that they're there, and we know that they're very, very bright. So what are they actually made from? Well, it turns out we think that most of Saturn's ring particles, we call them ringlets, are made from water ice. These are chunks of ice. Some of them are quite small, maybe just the size of your fist. Others might be as big as buses or even as big as hills or little small mountains. But they're all going around, and most of them are water ice, and there are some chunks of rock and dust and things like that as well. And we know what they're made from by light. We can use spectroscopy, which is reading the light, the way that the light bounces off or the way that the light travels through the rings can tell us what it's actually made from. We think that Saturn itself formed the same time the rest of the planets and the rest of the solar system was forming. And this was probably about 4.5 billion years ago. So that's billion with a B, so 9 zeros. That's a lot of time, right? And we think that the planets, they formed from the leftover material that didn't become part of the sun. The whole solar system, we think, collapsed from a nebula, a big cloud of gas and dust, which was the leftover material from the explosion of a previous star. And gravity pulled that material together, pulled it together. Most of it at the very center of the solar system became the sun. But this swirling material left over on the outside was what was able to form the planets. Now, Jupiter and Saturn are the most massive, meaning they're made of the most stuff of any of the planets in our solar system. So they ended up getting most of the leftover material. But in addition to Jupiter and Saturn, there are the other planets, and there are comets and asteroids and little pieces of stuff left behind. Well, we think that when Saturn formed, there was a ring of material around Saturn. Just like there was a ring of material around the sun, there was a little ring of material around Saturn. So one popular idea was that maybe these rings came from that early material, that disk of material surrounding Saturn. And in fact, we think a lot of Saturn's moons probably formed this way. And it's quite possible that rings of other planets could have formed this way too, like Jupiter's rings maybe came from the leftover material from when Jupiter was forming. Now, this was a big mystery for a long time. This goes back to our original question of why does Saturn have rings, which is kind of how did those rings form? And we didn't really know. And we still, in science, we're never completely sure, but we get really good ideas and we can support them with evidence. And recently we realized that there was a clue that we could use. Right? Understanding the solar system, understanding the formation of it, anything in space science, it's kind of like a big mystery novel, right? And the clue that we had was that, wait a second, Saturn's rings are made from water ice, right? Water ice is really shiny. That's why Saturn looks so bright in our sky, because the sunlight is bouncing off of those little particles of ice, kind of like a mirror. And that's why it looks so, so bright in our sky, because it has the sun's light bouncing off of it. So we said, okay, well, over time, those bits of ice, they should get dirty, right? Because space isn't actually empty. Compared to Earth, it might as well be, but there's actually little bits of dust floating around, orbiting around Saturn, orbiting around the sun, and the solar system is a pretty busy place. And so we know about how much dust there is out between the planets. So over time, Saturn's rings should get dirty, right? So all we need to do is we need to look at Saturn's rings and see how dirty they are. And we see that they're actually pretty clean. So that means that Saturn's rings can't be very old. Maybe our estimates are about only 100 million years old. Now that is not a lot, right? That sounds like a lot to a human, because humans, we don't live that long, right? But compared to a planet that's 4.5 billion years old, that's almost nothing. So we know that Saturn's rings probably are very new. So given that, what are the different ways that Saturn might have collected a huge number of particles of ice just orbiting around it? So our leading idea right now is that the ice that we see for Saturn's rings are actually the broken up remains of a moon that used to orbit around Saturn. So this moon probably formed from that early disk of material around Saturn we were talking about. And it was mostly water ice and some rock and some metal. But over time, that moon got a little bit closer and a little bit closer to Saturn, just a little bit closer, until it got so close it crossed over a very special limit that we call the Roche limit. And this is where Saturn's gravity would have become so strong that it actually pulled apart this moon. This small ice planet got pulled to pieces, and the pieces, the remains of that, have continued to orbit around Saturn as its beautiful rings. Now, in many, many years, and hundreds of millions of years from now, those rings, those little ring particles, will probably fall out of Saturn's sky. And there won't be these big, beautiful rings around Saturn anymore. So we actually live in a really special time in the solar system that when we look at Saturn, we see these incredible rings made of ice particles of a broken moon. All right. This is a good place for us to pause for this episode. But once again, this was a fantastic question, a lot to dig into. If you have any questions that you would like to ask on the podcast, have us answer here in an episode, go ahead and follow the link. Have your folks, have your grown-ups help you with this. There's a link in the description in the show notes that you can use to ask your questions. So thank you so much, everyone. Remember to stay curious, and I hope you have dark skies. See you next time.